So now we're going to talk about quantified statements. So we're going to start with the definition of what a predicate is. A predicate, and this is sometimes called, I think your book calls it an open sentence, is a sentence with a finite number of variables that becomes a statement when you substitute in for the variables. So let's look at an example here. We're going to say let Pn be the predicate 2n squared plus 5 plus negative 1 to the n over 2 is prime. That's my predicate. Be a predicate with domain positive integers. So I have one variable here, and what happens when I substitute in for my variable? So for example, if I plug in 1, what will this become? If you plug in 1, the number you're going to get is 3. It says 3 is prime. So this is a statement now, and this statement is true. If you plug in a different number, let's plug in 5, and if you simplify that, the number you should get is 27. Say 27 is prime, and in this case, it would be a false statement. Now, with these predicates, we had quantifiers. So we had 2 of them. There was the universal quantifier. It was this upside down A symbol, and it means for all or every. And then we had the existential quantifier, which was like it was backwards E, and it means there exists. Another way you can think of it is there's at least one. So let's look at some examples of these quantifiers. So there exists a real number x such that x squared equals 3. So which type of quantifier is used in this statement? It's a existential quantifier. And we can ask if this is true or false now. And we would say that this statement is true. One such value, we only have to have one value for x, and square root of 3 would work. Would solve that equation, but that's not the only option. You could have also chosen negative square root of 3 as well. Now what if I change to the universal quantifier? So if I say for all real numbers x squared equals 3. Would that be true or false? That would be false, because there are some numbers, some real numbers, when you square them, you don't get 3. So, for example, if x equals 0, 0 squared is 0, which is not 3. And then finally, I want to talk about how we negate these quantifiers. So remember, when you negate quantifiers, what happens is they flip. So here I have the universal quantifier. When I negate it, it's going to become an existential quantifier. There exists an x in R in the real numbers such that x squared is not equal to 3. And you've also got to remember to negate this. The opposite of equals is not equals.